Okay, some people have asked for the Series 9, number 3 FRQ. Stop it and pause it. If you feel like you get it, pause it and then just go ahead and work through the rest of it. I want you to do it as much as you can on your own, but also want to make sure you get little helpful hints as we go along. So, okay, the first part, it gives you the information. It tells you that the series is given by this series, is the Taylor series, and they tell you it converges, which means that you should be able to find a radius of convergence. Now, the first thing I would probably hope for is that this would be geometric. But given the way the questions ask, I'm going to assume in order for me to get a radius of convergence, two choices. Either it's geometric, or second thing, it's you can find an R using the ratio test. That's the choices. So what I'm going to do is I'm going to find the R using the ratio test. The ratio test is the limit as n approaches infinity of the a sub n plus 1 over a sub n term. So, and remember it's divide by, and we're going to wind up with fractions. So instead of dividing by, we're going to multiply our reciprocal. So limit as n approaches infinity of the a sub n plus 1 term. So I'm going to take this right here, and I'm going to plug in n plus 1 for n. So if I plug in n plus 1 here, I get n plus 1 plus 1. So I've got negative 1, n plus 2. Take out the n, put n plus 1 in its place. 2n plus 1 over n, take that out and put n plus 1 in its place. Then x minus 1, n plus 1. That's my nth term. Now I'm going to take the a sub n, instead of dividing by, I'm going to multiply by its reciprocal. So the only term I have here that's on the bottom is n, so I'm going to put it on top. The rest I can put on the bottom. So negative 1, n plus 1, 2 to the n, x minus 1 to the n. Okay, now we got to tidy this up a bit. Again, I'm trying to find a radius of convergence, which means I need the interval of convergence to do this. So I'm creating the R by using the ratio test. So I'm going to reorchestrate this. I'm going to put, I've got negative 1 here and the negative 1 here. I'm going to put those on top of each other. Then I've got the 2 to the, I'm going to put those two together. Or even better yet, let's do the n plus 1. It doesn't really matter. N over n plus 1 kind of fit together. And then times 2 and the 2. So 2n plus 1 over 2n. Times, now I'm going to put my x minus 1s together. So x minus 1 to the n plus 1 over x minus 1 to the n. So I've kind of reorchestrated it. Yes, I should have brought the limit down. Equals, limit as n approaches infinity of, now the n plus 2 and n plus 1, there's 1 extra at the top. That means I'm left with a negative 1. Then I've got this guy. This piece right here is the only thing that's not going to reduce. So I'm actually going to do its limit. If I take the limit as n approaches infinity, I get infinity over infinity. Since it doesn't reduce, I can use L'Hopital's rule. By L'Hopital's rule, by La Hope, I get n over n is 1 times, now I've got 1 extra, in this term I've got 1 extra 2 at the top, so I'm just stuck with a 2. And then here I've got 1 extra x minus 1 at the top, so x minus 1. So this is our arbitrary R. Now that I've taken this limit, I have my R is negative 2 x minus 1. Okay, now if it's going to converge, it has to be in between -1 and 1. Multiply both sides or divide by -2. Gives me 1/2. Now the symbol must switch because I've divided by a negative. And this was a bad order for this, so I'm going to switch the 2. Add 1. Which tells me that the whole distance from here to here is 1, so my radius is half of that, which is 1/2. That's the first part. Second part says write out. See, sometimes actually that part was actually harder than the second part. So never assume that if you can't do part A, you can't do part B. Part B says write the first 3 non-integers of the derivative. So of the derivative. So the first thing I'm going to do is I'm going to go ahead and write, this is the function. I'm going to write out the function first so I can take its derivative easily. So, and I need the 3 non-zero terms. So let's see. I'm going to write f out. So I plug in 1. So I plug in 1. I get positive 2 to the 1 over 1 x minus 1 to the 1 plus, now I can plug in 2. If I plug in 2, this gives me an odd power, so I get -1 times 2 squared over 2 x minus 1 squared. Then I get plus, plug in 3, I get even power, so it's positive 1, and then 2 to the 3 over 3 x minus 1 third factorial. So I have the function, it's plus dot dot dot. Let's simplify it a little bit. I've got 2x minus 1 minus 2x minus 1 squared plus 8/3 x minus 1 to the third plus dot dot dot. Okay, so I have the first 3 terms of the function. Now it's going to be easy for me to take its derivative. Remember, we're taking a derivative of the variable part only. My variable part is here. I've got x. Take the derivative of x, you get 1, so this is just 2. Take the derivative of this, treat it as u squared, so put the 2 out in front, so it's -4 x minus 1 times the derivative of the inside, 1, plus, taking the derivative, think of this as u to the third, bring the 3 out in front, leaves you just 8 x minus 1 to the second times 1 plus dot dot dot. Okay, so there is your derivative, the series for the derivative. The question also says, it says find the first 3 terms, which I did that. Now it wants the nth term. So I'm going to do that separately and treat it as a separate kind of problem. All right, so this right here is the nth term. Now it looks complicated, but I'm going to take its derivative. Okay, all of this part here, everything but the variable part, no different than down here. No different than when I took the derivatives down here. No different. All this junk here, all of this is the coefficient. That's the only variable part. So this is not going to change. Okay, so I'm going to write, so I'm going to take the derivative of this, so plus dot dot dot, but here I'm going to add my nth term. So I've got the coefficient stays the same. And now I'm just taking the derivative of this part only because it's the only part that has a variable. So what do we do every other time? We put the, treat it as u to the n. N goes in front. X minus 1, take 1 off the power, times the derivative of the u, which is 1, and there I have it. I have my nth term. Again, don't be too fussy about simplifying it, but your nth term is already predetermined. However, I probably would like to get rid of these n's because they cancel. So when I finish off my problems to show my nth term, I can write it right here. Negative 1 to the n plus 1, 2 to the n, x minus 1 to the n minus 1. I've completed both parts, and I double reread the question, and it did say find the first non-zero terms, 1, 2, 3, and find the nth term of the derivative, and I did that. Okay, so we're set on that part. Part C. Part C. Let me read the question here real quick. All right, part C says, use from part B, the derivative that you got, and this is what I got, and I just copied it down for you already. There's the derivative. It says find the function for r. It tells me that the derivative is in fact geometric. So in order for me to write the function for the derivative, I need to do a over 1 minus r. My a is 2. My r is what am I multiplying by each time? Well, we did that in the ratio test, and it should be the same. Each time I multiply by negative 2, so negative 2. Then each time I'm multiplying by x minus 1. Oops. So there's a over 1 minus r, and this, we got to tidy this up a bit. So equals 2 over 1, double negative is plus, so I'm going to distribute my positive 2. Which leaves me with the function for the derivative to be 2 over 1 plus, I'm sorry, let's write it this way, 2x minus 1. So there is my function for the derivative. Okay, now the second statement or part to the question says find the function, the f. We just found f tick. This is f tick, and now they want the function. The only way to go from the derivative down is to integrate. So the f is the integral of the derivative. But keep in mind, this is just going to have a plus c in it if I take its integration. So let's integrate 2, I can actually put 2 in front, 1 over 2x minus 1 dx. This is a u substitution, 1 over u, I hope. U equals 2x minus 1, du equals 2 dx. So the dx is actually equal to 1/2 of the du. So substituting, you already have a 2. Integration of 1 over u dx is 1/2 of the du. So times 1/2. That leaves me the integration of 1 over u du, which is ln absolute value of u plus c, which equals ln absolute value of 2x minus 1 plus c. All right, now here's the hard part. This is actually a general term for my function. I need the specific function. which this part is the part that's difficult to see, and you get stuck here, that's fine. Keep in mind that that doesn't preclude you from a significant amount of points. Keep in mind I need an initial point. I need an x and a y to find c. Note that they told me that the x is 1. Now if I need the y, I plug it into the function, which was a series. And this looks very complicated, but look, x equals 1, and I put 1 minus 1 in here. Each term is going to have a 0 to the n power. That means the whole thing is going to wind up being 0, which tells me my initial position was 1, 0. Not so directly intuitive. However, I just followed instructions. I knew that x was 1. I plugged it into my function to determine its y value, and that gives me my initial position. My initial position allows me to come over here and finish up this problem. So y is 0, ln 2 times 1 minus 1 plus c. 0 equals ln 1 plus c. ln 1 is 0, so c is 0. Leaving me with the function equaling ln, I'm just plug my c back up in here, ln to x minus 1. And that is QED. Now technically these were all bounded, so I would probably have to say 4x minus 1 less than r here, and I'd have to write it here too. Not the end of the world if you don't, but they defined it that way, so I defined it that way. Keep asking those questions.